demonstrates a particular type of motion called rotational motion. It rotates around a fixed axis in a circular motion. In rotational motion, the axle at the center of a wheel remains stationary. The wheel or the object never actually changes its position. We can take a wheel and mark a point O on the rim of the wheel as the reference orientation. This is the point from which the wheel changes its angular position. As the wheel rotates, its angular position constantly changes and is relative to the reference orientation. Angular displacement measures how far the wheel is rotated from its reference orientation. This is the angle formed between point P and the reference orientation O. The axis Z represents the axis of the wheel, while the axis X represents the reference orientation. Angular velocity or rotational velocity gives us the angular speed of an object and the axis about which the object is rotating. Consider a case in which the angular velocity in rotational motion keeps changing. Angular acceleration takes place. Angular acceleration is directly proportional to the change in angular velocity. Angular velocity has both magnitude and direction. The direction of angular velocity can be determined using the right-hand rule. A wheel can rotate in the clockwise or anti-clockwise direction. If we curl our fingers in the direction of rotation, then the thumb will give us the direction of angular velocity. So if the wheel rotates in an anti-clockwise direction, then the direction of angular velocity is upwards. Angular velocity also changes when the rate of rotation increases or decreases. Once a wheel is in motion, it takes a certain amount of force to stop it. The force required to stop a wheel is equal to the product of the mass of an object and the square of the distance from the axis to the particles that make up the object. This force is known as a moment of inertia, equal to mr square. Angular momentum measures an object's tendency to spin. It is the product of the object's moment of inertia and its angular velocity. A Ferris wheel works on the principle of rotational motion. Its angular velocity is affected by the rotation rate of the wheel. It is also possible to determine angular acceleration, angular momentum, and the moment of inertia.